All right, so this is the first video for Chapter 3, and what Chapter 3 is about is looking at equations with two unknowns. And before we get too far down that road, we're just going to introduce some ideas here in 3.1, kind of what graphs are about. And graphs are something that, it's another one of those things that for some people, fractions are the thing that really stresses them out. For some people, graphs are something that really stresses them out. So we're going to start by just introducing what this is about. This is called the Cartesian plane. It is also often called the rectangular coordinate system. So rectangular coordinate system. And what this represents is, it's actually a really big deal. It is a connection between algebra and geometry. So it's a connection between algebra and geometry. This was, and I think this is one of those things that's presented as, we learn about it when we're pretty young, but it's actually, so the reason it's called the Cartesian plane, and the book just calls it the rectangular coordinate system, and that's fine, but it was invented by René Descartes, and Descartes is pretty tough to spell. He was French. And this was invented in the early 1600s. That's not how you spell early. And so the early 1600s, you hear that's a long time ago, but a lot of the math that we've been looking at is much, much older than that. Like a lot of this algebra stuff, even things like the quadratic formula, those things were in use in the Babylonian civilization. So very, very old stuff. And the early 1600s is an exciting time for mathematics because this is kind of right before things exploded. 1666 is when Isaac Newton invented calculus. That totally revolutionized the way that physics and mathematics interacted. And one of the things that really allowed that to happen is the ideas of the coordinate plane, because what that is going to allow us to do is look at geometric objects like lines, and if you take later classes like parabolas, circles, all kinds of things, and we're going to be able to look at them as an equation. And before this happened, before the 1600s, that relationship didn't exist. And if I wanted to talk about a circle, I couldn't use an equation. I had to use a compass and a straight edge, which is a whole nightmare. It's cool, but if you've taken a geometry class, you maybe done some of those constructions, but we're not going to worry about that here. We're going to look at the algebraic aspects. So this is it. This is the big invention, the coordinate plane. All it is a number line, just like the number line we looked at in 2.8. We've got the x-axis. We've got 0 right here. It's going positive in this direction. So this is the positive x-axis. And then the negative, it goes negative in the other direction on the x-axis. And then all we did is took another number line here and put it vertically across. So this is the y-axis. And that goes positive in this direction, and it goes negative in this direction. It looks like I forgot to label the x-axis here, but yeah, this is the x-axis. Okay, so what this does is it divides this infinite two-dimensional plane into 4 sections, and any point on here, if I just choose some random point in space, let's do this, any dot I make on this surface is going to line up with some x-coordinate and some y-coordinate. And so what we can do is label this point as 2, 3. And this is something I'll talk a little bit more about the way these ordered pairs work soon, but it's always going to be the x-coordinate and then the y-coordinate. So every single point is going to line up with two things. If you've ever played the old game Battleship, it's a lot like that. Let's see. So all of these points in these four areas, like you can see this one, it lines up with +2 and +3. All the points in this are said to be in quadrant 1. And every point in quadrant 1 has a positive x and a positive y value. And the quadrants go around like this. So over here I have quadrant 2, and every point in quadrant 2, now they're all on the negative x side, so they have a negative x coordinate, and then they're going to have a positive y coordinate, like that. Then down here I have quadrant 3, and you're not going to like really have to memorize these quadrants, but it is something we'll refer to now and again. And then over here we have quadrant 4, where I have positive x values and negative y values. Okay, there's one other really important point I want to mention here on the coordinate plane, and that is this guy. So right there, that is the point between -1 and 1, so it's 0 on the x-axis, it's 0 on the y-axis. That point is the ordered pair 0, 0, and it has a special name. It's called the origin. So the origin is the point where these two axes cross. Okay, I'm going to scroll down a little here. Okay, so an ordered pair is, and the structure of an ordered pair is really important, and it's really specific. So it's always parentheses with a comma, and then the first number in the ordered pair is always the x-coordinate. So it's always, the first number is the x-coordinate, and the second number is the y-coordinate. So fortunately, if you do get confused about which is which, it is alphabetical, so it's not too bad. Here we're going to plot some points, and this is something maybe you've seen point plotting before, maybe you haven't. So I'm going to give a pretty detailed explanation here, and even if you haven't, it's really worth giving some time to this because it can catch people off guard a little bit sometimes with negatives. So the first step is find the x-coordinate on the x-axis. Find the x-coordinate on the x-axis. So for example, let's look at this. This is supposed to be 5, 3. So if I have 5, 3, my x-coordinate is going to line up with this 5. So here's my 5 on the x-axis. I'm just going to draw a vertical line here. So any point on this line has an x-coordinate of 5. Then my next step is to find the y-coordinate on the y-axis. So for this point, 5, 3, my y-coordinate is 3. So here's 3 on the y-axis, and this is the line that goes through that. Then the ordered pair I'm looking for, so in my case, my ordered pair 5, 3 right here, is where these intersect. So right here, that's my ordered pair. The ordered pair is on this intersection. The ordered pair is on this intersection. So that's a point that it lines up both with 5 on the x and with 3 on the y. So I'm going to plot a few more of these. Oh, and I also want to talk about, so now this is in quadrant 1. So this point is in quadrant 1. And you're not always going to have to put that, but for this example, I'm going to talk through that. -5, 3. So here I'm going to find -5 on the x-axis, because that's my x-coordinate. And then 3 on the y-axis is still right here. So this is my point -5, 3. And that is in quadrant 2. negative 2, negative 4. I'm going to find negative 2 on my x-axis right here. The negative 4 on my y-axis. So my point negative 2, negative 4 is right here. And that is in quadrant 3. And then 1, negative 2. This has an x-coordinate of positive 1 and a y-coordinate of negative 2. So now these dotted lines, you don't need to actually draw those every time. You're welcome to, but where this point actually is, all I need to do is I find 1 on the x-axis, I find negative 2 on the y-axis, and I can kind of just visualize those lines, and it's right here. 1, negative 2. And that now is in quadrant 4. We already talked about this special point 0, 0. 0, 0 lives right here. It's called the origin. And that is not in a quadrant. So that's just a special point. It's on the origin. And because it's not in this space, it's on one of these axes, or what these are called, it doesn't... It isn't considered to be in a quadrant. Same for the point 0, 2. So 0, 2, I'm going to line up with 0 on the x-axis, so that's right here, and then 2 on the y-axis, and because it's at 0 on the x-axis, it's going to be right on the y-axis itself. So 0, 2 is where that is, and that point, again, is not in a quadrant. That's just right on the y-axis. You can also think about it as I go over 0 and then I go up 2. Sometimes people like to think about it like that. Negative 5, 0. On the x-axis, I have negative 5. And then on the y-axis, I want to line up with 0. So that's right on that x-axis. Right there. I have the point negative 5, 0. 0, negative 5 halves. So I can have these values don't have to be integers. I can have fractions. That's fine. I'm going to go 0 on the x, and then I'm going to go down 5 and a half. So right here. And kind of the nice thing about this is you just make a nice dot there, and then, you know, I don't know whether that dot is exactly perfectly on negative 5 halves, but I'm just going to label it 0, negative 5 halves, and that's good enough, as long as it's around the right area. 4 2/3, negative 3. My x-coordinate is 4 2/3. My y-coordinate is negative 3, so for x, I'm going to go over 4. And then if I kind of think about that area being divided in thirds, 4 2/3 would be right there. And then I'm going to go down 1, 2, 3. So that's going to be my point that lines up with negative 3 on the y-axis and 4 2/3 on the x-axis. And I'll label that 4 2/3, comma, negative 3. Okay, so that's it for page 1. Let's go on to page 2. All right, here on page 2, what we're going to do is look at what these ordered pairs mean for solutions. So equations, we're going to look at equations and ordered pair solutions. And we'll be asking questions like this. Is the pair of values x equals 3, y equals 2, a solution for the equation 2x plus y equals 8? To find out what I'm going to do, we replace that x with 3 and y with 2, and then I'm going to go in and simplify, and then I'm going to look and see if I get a true statement or a false statement. So here, what this represents, x equals 3, y equals 2, that's an ordered pair, 3, 2. And then an ordered pair is always in parentheses with those with that comma. So what I'm going to do is take my formula 2x plus y equals 8, and now I'm replacing x with 3, and I'm replacing y with 2. And then when I go through and simplify, I'm going to see what happens. So here I have 2 times 3. 2 times 3 is 6, plus 2 equals 8. And now I've got a good feeling about that, but I'm going to take it all the way to 8 equals 8. And now that is a true statement. And so what it all comes down to is whether this statement is true or false. So this is true. So because that is true, 3, 2 is a solution. Because 8 equals 8 is a true statement. That means that ordered pair 3, 2 is a solution to the equation (2x plus y equals 8). I could also say that the ordered pair 3, 2 satisfies the equation 2x plus y equals 8. Okay, so here we've got some group problems. I'm going to scroll down here. Okay, and now what I want you to do with these ones, you're just going to go through and do pretty much what I did up there. You're going to take these ordered pairs where always this first thing is your x. So this is your x, the first coordinate. The second coordinate is your y. And you're going to take those, plug them into that equation, and either that equation is going to be true or that equation is going to be false. And I don't want to see people, this always happens, and now normally when you do group work, I'm right here so I can walk around and bother you, but people always are going to, I walk around and people do these and then they start to do these, and I want you to do this fraction problem. Get the most practice doing fractions you can in environments like this where you have an opportunity to go slowly, to reference things, to be careful so that you're ready when this stuff shows up on exams, because it will. So make sure you don't skip that fraction one. The other big thing with these group work problems is these are a typo. So just get rid of these 3 ordered pairs. And now what you're going to do is complete the ordered pair to find a solution. So here is an example of what's supposed to be here. This first one is supposed to say 1, comma, question mark. The second one is supposed to say question mark 0. And the third one is supposed to say 10 question mark. So the idea is I want you to find out what the question mark is. And I'm going to go through one of these here, and I'm going to scroll down. So like for this first one, 1 comma question mark, that means I'm going to take this equation, 3x plus y equals 12, and they're telling me that x equals 1 and y equals an unknown thing. So what I'm going to do here is I'm going to replace that x with 1. So I have 3 times 1 plus y, because I don't know what y is, so I'm just going to leave it as y. And so now I have this. And to figure out what y is, I'm just going to go through and simplify, because the ordered pair solution that satisfies this equation is going to be something where if I plug these 2 numbers in, it will satisfy this. And if x goes in here, To find out what y will satisfy that particular x value, all I have to do is take this and solve it for y, just like I was doing in chapter 2. So one of the really nice things about this chapter is it is full of chapter 1 and chapter 2 review. So y equals 9 is the y value that goes with that x value, so that means my ordered pair solution is 1, 9. And so you're going to do that same thing for these other two, and I will have all these solutions up on D2L. Cool.